Hey everyone, and welcome. My name is Klaus, and I'm here. Alexander is unfortunately having a trouble joining for this webinar, so you may have to, deal with me. So let's get started. I do actually have a little issue with seeing my own presentation, so let me just redo here. Computers, they don't seem always to work the way they're supposed to. So welcome again, and I'm here to give a talk about integration using Apache Camel and Quarkus. So what is Camel? Well, Camel is the Swiss knife of integration. It's actually a giant Swiss knife because Camel comes with a lot of functionality. So Camel is an integration library. So you use Camel for integration. Yeah, okay, go figure. But what Camel is famous for is that it can integrate almost everything. Camel comes with more than 360 components for connectivity. So we have connectors for many different things. You can work with, files, plain files, any kind of files. You have messaging systems and networking protocols, IoT systems, and the big public clouds with Amazon, Azure, and Google and Hawaii clouds and others to come as well. We have social media and many other connectors. So there's a lot. Okay, but as a developer, this is where essential with Camel is that when as a developer you need to integrate with Camel, you use Camel routes. So what you do as a developer is that you specify how systems are integrated using routes. And for that, we have a domain-specific language, which essentially is just Java code or XML or Kotlin and Groovy and so on. So what you see on the slide here is the same integration, one in Java and another one in XML. So basically what we're doing is to pick up some files from Amazon S3 bucket, and then we send them straight to a Telegram bot. So from the source endpoint and to the sync endpoints and so on. Pretty straightforward to do. Now Camel is just a library, so basically you can use and run Camel anywhere where you can use Java. So over the years, can you run Camel instead on Tomcat and old application servers, and you can run it on more modern runtimes like Spring Boot and Quarkus. And what we're gonna see also in this talk is Camel is truly cloud native on Kubernetes. So Apache Camel has an awesome community. It's one of the largest open source integration software community. We have a lot of contributors to the product over the years. And Camel is actually a rather established product. It's been around for 14 years, and that's quite a long time. But as you can see from the slide here, there has been activity in the product always over the many years. Now, you may have a question saying, why the hell should I care about a 14-year-old Java framework in today's modern world with cloud native and Kubernetes and things like that? And that actually is a great question because, essentially Camel was created before the cloud. It was created before Kubernetes. It was created before GitHub and whatnot. But Camel has been through all that evolution over the time. So it, has been relevant for, let's say, the old ways with application servers, and then through gradually with cloud and Spring Boot came and Quarkus and so on, now with Kubernetes, GraalVM and things like that. So Camel has always been able to adapt to the current world and what comes for tomorrow. And actually, Camel is more relevant today for tomorrow's workload on cloud native. But what I'm going to touch on is to what we've done to make Camel, particular Camel 3, relevant for the cloud. So in Camel 2, we had a monolithic project. There was one project with just Camel, one project. So what we've done is to separate that into multiple projects. So we have Camel as the core project with the Swiss knife, the Swiss knife of integration. You can run Camel on Spring Boot, and there's some legacy or something for OSGI, which is based on Carafe. And then there's the awesome technology with Camel K we're gonna see more about in this talk. And then we have Camel for Quarkus, awesome framework as well with Quarkus. And this is really fantastic to make Java awesome for more today's and tomorrow's workloads. And for Kafka, there's also connectors for using Kafka connector technologies. And actually, there are a couple of more products, Camelot, which we're gonna show later what that really is. And just recently, there was a prototype for sort of like an integration designer for some Camel tooling. Camel Caravan is just sort of being formed and established. But there's also another team working on something similar, but with a wider goal. So pay attention to that as well. So there are some tools coming with the Caravan effort, and then the other team is working on what is known as CMR. So just what have we done to make Camel adapt and relevant for the cloud native world in Camel version 3? So I'd like to focus on 3 aspects. One is that we have make sure Camel is highly optimized for that world where it has a very fast startup and low memory footprint. And for what we have done is to, in Camel 2, there was one monolithic product, but there was also one monolithic jar itself, Camel Core jar. So what we've done is to modelize that jar. And now pay attention, we modelize that single jar from 1, and now don't fall off your chair, to 42 jars. That's quite a lot of things, but that also allows us to, be efficient and take advantage of for something like with Quarkus, where you can do build time optimization based on which modules are available on the class part. And if a module is not available on the class part, then it's not even in the JVM and used at all. Whereas on Camel 2, it will be present, right? So that's a significant work to reduce, let's say, the footprint of Camel itself. We have heavily optimized the routing engine inside Camel to make sure it only execute necessary routing logic that are enabled. If something is not available, not enabled, and so on, it will not even execute that part. Collapse the number of methods that undergoes during routing of message. Now, another significant one was to reduce the memory footprint of Camel itself. So we have restructured and found different ways of keeping track of message during routing using that, the state engine inside Camel. So we have reduced the memory overhead of that. In fact, it's dramatically reduced. So Camel 3 is using less memory on the Java heap than, let's say, a logging library like Log4j does. So basically, a small Camel application just by Camel and the JVM itself running, it takes less than 5 megabytes of the heap, and that's including the JVM. In fact, it was about 4.5 megabytes. Camel has also been reduced, the necessary number of objects being allocated during routing of message. We'll see some slides next about this. And we made Camel reflection free, and we have phased that up now. We have a build phase that in the particular use for cloud native with Quarkus and so on. So a lot of going on there. Now, this is a slide about some of the effort we did about reducing memory allocation. So this is basically a print from Java flight recorder. So we have profiled a Camel application, a basic Camel application with a route, but does content-based routing and many other things, as if it was a real life application, but it was based from a timer source. Nevertheless, you can see during that 10 minutes period where it was profiled, we processed 1,000 messages per second. That means 600,000 messages in total, and that allocated about 600 megabytes or so by the kind of that thread. Now, with some optimization and let's say a feature we added into our Camel where we can reduce object allocation and also recycle objects between the different messages. So when the Camel is finished routing a message, it can actually recycle that object holder for the next message and so on. And by that, we were able to reduce that to no objects allocated at all. So Camel keeps track of all the messages, in case of redeliveries and many other things going on that are part of the routing engine, but the Camel does not allocate new memories objects during that period. So that's a hefty optimization in Camel to reduce the footprint of Camel in cloud native, to make the memory usage more stable. Now, there's one thing you will say, hey, Claus, are you not cheating? No, I'm not. But one thing we can never allocate is the message payload itself. So let's suppose you have a Kafka source as input and you send it to a S3 bucket. Then the actual message itself from those messages coming from a Kafka to sending to those, of course, is being allocated in the memory. But Camel, the overhead of Camel is almost zero during that period. Now, I added this slide because I like the logo here. The Kubernetes logo is sort of like a prize, first prize for Camel. Camel is cloud native. And by that, we say it's mostly these products that are focusing on Camel being cloud native, the core product, but also, of course, with Camel Quarkus, which is a fantastic framework for running Java on cloud workloads, and Camel K, which we're going to see in a moment. Now, when we move workloads in the cloud native world, then there's also opening up the possibility for, let's say, a new set of users. So what we've done for Camel 3 is to make it polyglot in the sense that you can specify your Camel integration in different programming languages. It doesn't have to necessarily only be a big traditional Java product, but you can also use other languages like Ruby, Kotlin, JavaScript, and others to come. I'm looking at we're looking at adding support for Python next. The IBM team for machine learning AI have built a Camel K based platform on top of that are using Python that integrate with their system, Ravens. So we're going to collaborate with that team and then get their experience from that and then get Python DSL into Camel. Now, there's also support for markup language where you can traditionally use XML for defining routes, but there's also to be, Kubernetes buzzword compliant. There are Kubernetes very friendly, then you can actually also use YAML DSLs. So you can have some fun there, where do I need to add a couple of spaces to make this YAML valid? But it's actually working quite well in that space with Camel, as we're going to see in a moment. But nevertheless, Camel is also very flexible. So if you're not satisfied what we have today, you can of course plug in your own route loaders. And actually, there are some people doing that in the past. We have customers and users of Camel where they have their routes in a database. So basically, you boot up your application, it connects to a database and reads what Camel has to do. Now, the last thing I want to say, what we did for making Camel really efficient for cloud native workloads is to also make it very configurable, but also very let's say efficient in that regard, because workloads in a cloud native world means that we see a trend where you code less but configure more, in the sense that you can specify configuration many different places, configuration files, properties and YAML files with Quarkus and Spring Boot, etc. But you can also take any configuration from the environmental variables, JVM system properties, config maps, and secrets from Kubernetes. And in Camelot, you can also use these double parentheses as a placeholder to refer to a property value. And in Java code, you have all these different annotations as well. So there are many different places where all this configuration can come from. And then when Camel boot up, it takes all that configuration from different places and build that integration. But we have done this in a fantastic way with Camel 3 to make all that reflection free. So it doesn't matter if you have configuration in YAML files or something in code and whatnot, all together when that are configured inside Camel is just traditional Java code. Okay, I'm actually lying a little bit. There are two logos on the slide. You have Spring Boot and you have Quarkus. One of them is not reflection free. Which one could it be? Jesus, I wonder. I'll let it up to you to guess which one it is. So let's talk a little bit about Camel K. So what is Camel K? Well, it is the most innovative recent product with Camel, I will definitely say. So it's integration that are Kubernetes native. And actually, I think it's better to explain it with a little demo. So let's exit this one. So I have a terminal here. Yes, I went for black this day, a black t-shirt and black terminal. So I have a Camel K installed inside a little Minikube installation, and I'm using Camel K 1.6. In the namespace, I only have Camel K installed, and it is installed via an operator. So there's a Camel K operator running, and you're going to see in a moment what that means. Basically, with Camel K, then it actually makes integration just about a single file, not about a traditional, let's say, Java product where you have Maven or Gradle and multiple modules and build them and all those kind of things. So it puts integration, a single file in the focus. So this is where you can write this DSL code to what you want to integrate. So the Camel CLI has a little sub command to initialize a project, basically just create a file for you. But let's call it a beer. And we can use Java code, but you can also use JavaScript, Kotlin, and so on. So now I have a file here, beer Java. That's the only, there's no name and whatever. So I'm going to open that in Visual Code here. So in Visual Code, we have plugins for working with Apache Camel, and there's also plugins for Camel K, so you can install both of them. Basically, there's no memory product whatsoever, so but Visual Code has been able to adapt anyway and understand this is Java code. And you may see this is the secret source. So there's a Camel K comment here saying this is a language Java. So the tooling understands this. But basically you write Java code here, whatever you want to do. I have to forgive me, but I'm not using this editor normally, but you can use system out print line, and apparently it shows the documentation immediately. But basically just want to run this one. So I can go back here and say camel run beer Java, and then it starts that one. Let's see, K get pods. So stern beer. So stern is a way to quickly log from your containers. So you can see here it running the application. It says hello Camel K from Java. So there's that integration is running. If I go to the tool here, I should see I can see the beer integration running here, and I think I can also delete it if I want. I can follow the logs. I can see it from this one. It will also show the logs, and of course I can change the source code and start and stop it and so on. So I can say remove that one. I can make this a bit quicker, 1, 2, 3 instead, and let's go down here. The tooling should have some sort of support for Camel. So this is sending to a log endpoint, and there are some options on the log endpoint in Camel, and you can see the tooling actually understand these one. These are the options you can configure on a Camel endpoint. So I can say multiline equals true, for example, and I can run this one again. And if I want, I can also run it from a command line, camel run beer Java. And if I want, I can say dev mode. So this is like the Quarkus dev mode. If you've seen Quarkus, the tooling that's really fantastic. You get a sort of like a similar experience where it will just constantly redeploy the application when you do code changes. It's not as, it used to be a bit faster, but I'm using my old laptop, so this is not the quickest turnaround. But let's see here. If I go in here and I change this one to be slow again, give it 2 seconds, and I just say can 2 just to be something different. I save the file, and you can see it will do a redeployment of the container. So it takes a little while to shut it down. There's so many in-flight messages, so apparently it does take a while for it to restart. Now it's starting to restart. It has to do a graceful shutter, so it stopped the Java application, and now it starts it up again. And it started again, yeah. So now you can see it running with 2 seconds. And if you pay attention, then you can see Quarkus is actually running in here. Quarkus somewhere. I have a big font, so I can't really see it, but it's in there. Quarkus is fantastic. So Camel K runs on top of Quarkus. And that's a bit it. Let's go back to the slides and we'll get back to the presentation again, or demos again. So yes, my favorite camel, Lego camel, Lego from my home country in Denmark. So what happens under the scene or under the hood a little? So what we did was to use a Camel C like command line to run an integration. Basically just say camel run and the name of the file. On the slide is actually the YAML DSL, but you can also use, the other language. So what happens is that the CLI will then take that file and install that inside the cluster as a custom resource definition. A custom resource definition is a way of extending Kubernetes. So we have an integration, custom resource definition, kind integration. So basically that one is creating that CRDs in the cluster. Then the operator watches these CRDs for changes, and then the operator is knows how to actually materialize that into a running container. So it knows, okay, I have all the dependencies I need to run this container. If not, I have to do build a new container base image and then deploy it and so on. So all the logics are inside the operator. There's no Maven, nothing like that. I only concentrate of the file, and that is really what's something that sets Camel apart from others. And at runtime, you get the same fantastic speed and performance, not on my slow laptop, but on a good systems with Quarkus and Camel Quarkus. So fantastic with that. And also for Camel K, the next version 1.7, we have our first support for being able to do native compilation as well. So you can basically say, I want to run this integration in the cluster, Camel run, and I want to run it in native mode. So it will be able to build it using GraalVM and all that. It just means that you have to have a beefy cluster to be able to compile it, because as you may know, GraalVM takes quite a lot of memory and CPU to compile it. So, oops, sorry, wrong button. I'm a bit clumsy. So let's move on. Now, the other thing that is really fantastic going on with Camel K for Cloud Native is that there's something called Camelets. So what is a Camelet? Well, there's something here on the slide, but you may not pay attention, but it's really just like a solution for something, a solution for an integration thing. So basically, just imagine that, a Camel component or connector is sort of like all, you can do everything. So if you have a Salesforce component, you can do everything with Salesforce, create a new account, get a new information, blah, blah, blah. Salesforce is a huge API. And so with others, even let's say a Kafka DMS system or RabbitMQ, because a Camel component exposes a lot of different configuration options. And basically what you want sometimes with the Camel is I just want a proven way of doing X. So for example, with a Salesforce, there might be a Camelet that can do, let's say, update an account. So basically you can find a Camelet for doing one thing, and then it's a sort of like a higher level building block on top of Camel that is pre-configured for that and doing that only one thing. In another word, with Camelets, we have sort of like a marketplace where you can go and find these things. Now, in the current marketplace, the most of the Camelets we have are focused on being a sink and a source, but there will be more to come in the future. So basically we have sources, to get some data into the system, and the sinks to send data out. And then we have actions where you can do all kind of things. It can be enterprise patterns, you can do message transformation, you can do maybe call a Google service or to translate. There's a translate action and so on. Like write something to be transform something to a PDF, and there are other actions. So basically a source and a sink and action, very high level. Now, if you go a little under the cover, what that is in Kubernetes is actually just a custom resource definition based on the kind Camelot. So basically that is what it is. So there's a specification for Camelot that are Kubernetes specific. So in the top we have the spec, which is basically some information about the name of the Camelot and where it's from, the provider, icon, and other things, what kind of type it is, source, sink, and so on. Then the definition part is sort of where you define the inputs, what options it takes as inputs, what is the output, and what let's say the data shape of the input and the output. Is it JSON? Is it XML? Is it arrow? Something like is there schema and examples and many other things. And also for the options, you can specify whether they're required or if it's a numeric or Boolean and enum and things like that. Basically something that allows tooling to understand this as well. Then the bottom part, this is where Camel comes into play, because there's a flow. This is the very specify, okay, what action to do. So this is basically what is in Camel lang. This is called a route template. So it's basically a template for Camel route where you can do all kind of things. And then you can take this template and instantiate as many times you like. And they can be isolated and so on. Okay, but that's basically it, what it is from the top. So let's go and look at a little Camelot demo. Now, unfortunately, Alexander is not here, so he had prepared a great demo with knative. So you have to bear with me where we go a little bit slower and show you with Camels only. So if you go to the Camel website, we do have down here the bottom for the Camel catalog that basically shows you the Camelets we have so far. The translate action, for example, if you want to translate, there's a number of options. You have to fill what language they can translate between, apparently Chinese, Finnish, and so on. And then you got some information about it. But basically that is sort of like an app store. What we're going to use is the Chuck Norris source. So basically that Camelot is able to get Chuck Norris jokes, and then we're going to just, lock them. So what you can do is to easily do that is to say, let me just find my previous command. So I want to say camel bind. I want to bind two systems together, and for that I can use Camel. So the from side or the source side is the Chuck Norris source, and for the other side I'm actually not using a Camel. I'm just using a Camel component, the log component in Camel, and saying, okay, the name of the logger is called joke, and then in the as the name I want to call this container funny joke. So that's all what I'm going to do, Camelot binding, and then I can say camel get, and then the funny joke is running, and I can say stern joke, this is what's going on, and that's it. I have nothing coded anything, I just type that command, and then the whatever magic happens inside Camel K kicks in. And here you can see some jokes about Chuck Norris. And if we go and look inside the container, the cluster, excuse me, then you can see there's the pod running here, the funny joke, and I can follow the log here as well. So every 10 seconds there will be a new joke from Chuck Norris. I can also go and see a little behind the scenes. So I go look on different resources. So I'm looking for a Camelot bindings, and there's the funny joke binding we created. Well, it was created from the CLI. If I look at that one, now forgive me, this is the first part, that's the icon. It's actually in base 64 format. But what you can see here in the spec. Now, unfortunately, YAML output from Kubernetes is sorted by alphabetics. So SI comes before this SO as the source, but the source is the input. So you can see the input is a Camelot, the Chuck Norris source, and there was no, let's say, options here. There's no, I could have specified a few options to it, but I didn't. I just used the default. And then the sync is just the Camel endpoint log joke. Now, if I would go and just go a bit out of the proven track, oh shit, this is loading the, yeah. So I'm going here and editing that CRD directly. So I'm going outside the so let me say here, I'm changing the CRD to load joke 2 and adding a parameter called multiline equals true. So this is a camel, a camel option. Now you can see the Camelot binding is being created again. If I go and look inside here, you can see the integration should be restarting because the CRD was changed. And when it runs again, it should say joke 2 somewhere, and it's multi-line now. Yeah, joke 2 over here. And now all the parameters are in multiple lines instead of a single line. So what I did here was to show you a bit behind the curtains what's going on. And so let's go back to the presentation because we are getting close to the Q&A. So what happens was Camel bind and from a source to a sink. That was, and I created this Camelot binding in the CRD. So actually what is now, we have the two layers. The first Camelot binding CRD, then creates another CRD, the integration CRD, and then the integration CRD have been watched again by the same operator, and that creates the pod and the container, etc. So it's like a double layer, right? Magic. But the Camelot binding can also be used for, other things. You can use it directly with knative if you don't install, to send to knative channels, Kafka using Strimsy and Camel itself, and maybe more to come in the future. And just want to give a quick teaser for that current tooling. There's tooling sort of like inside the VS Code here. We can drag and drop. So this is also create an integration with the Kafka source. filtering and then to its resource, all drag and drop kind of thing. To learn more about Camel, then a book was just published last month by Guillermo. It's cloud native integration with Apache Camel. I have my copy. I am halfway through it. I enjoyed reading it. It's very easy to read, and he has done a great job on the book, and also up to date on things with Camel. So there's no more demos. So let's go to the Q&A session. So I will stop sharing my screen so we can just go to the questions. Maybe over time. Can you use Camelot for serverless function calls? Yes, we have integration with the Amazon Lambda, for example, so you can call it, existing functions in a public cloud, but you can also kind of see Camel as a function as well. So you can actually create a very small integration that it does some function code. It could be a Camelot action. It could also just be a route where you just say from and then do some code in whatever programming language you like, the ones that Camel support. And so it can be very lightweight in that regard. So Camel can also be the function itself. I saw Spring Boot and Quarkus as being supported by Camel. Are there any other frameworks that Camel supports? Yes. So if you talk about Camel K itself, then it runs on Quarkus as the only runtime, to be the best experience there. But if you check the Camel product itself, you can run it anywhere you have Java. Spring Boot and Quarkus are, of course, the popular ones for microservice small runtimes, but you can use it in Tomcat, whatever standalone and other runtimes. It's just a bunch of jar files. So, and also one of the goals from the Camelot itself, if the Camelots you find on the website, on that website, on the Camel catalog, they can also be run outside Camel K. It's not tied to Camel K at all. You can run it in standalone mode on the Spring Boot or Camel Quarkus or on Tomcat or Carafe, whatever they are designed to be independent from the cloud. So you can actually also start to use Camelot as a higher level building blocks in those runtimes and not necessarily only on the cloud. Okay, that was the questions. So I guess we will wrap it up here. It's also 13, to the mark. So thank you for watching, and sorry for, let's say, Alexander couldn't join, so I had to, wing it here and there, but I hope you enjoyed it. Thank you. Bye-bye.